All right, we're going to look at some more examples of how we can take a constant rate and write an equation to be able to figure out more information. So Juan types at a constant rate. Okay, I'm thinking proportional. I'm thinking I can set up that proportion and I can come up with my equation. He can type a full page in 3.5 minutes. So this is one page. Might not look like we have something there in 3.5 minutes. And here's my time. We want to know how many pages one can type after t minutes. So notice it says write a linear equation in two variables. Okay, a lot of times people, when they have this question on their homework, they give me just the constant rate. No, I want a linear equation in two variables, x and y, or in this case, t and p. So remember, we always put our time on the bottom because I know he can type one page in 3.5 minutes. And you know what? I'm going to change that 3.5 to 3.5. Okay, pages per minute. So I can set that up, remember, into y divided by x. X is my independent variable. In this case, though, I'm going to kind of skip a step. Instead of changing my variables at the end, I'm going to write them this way now. My y is pages, so that comes on top. My x is time, so my t comes at the bottom. And so notice my pages and my time together. Now I can do my cross products to solve for, and I'm solving for p, which is the y, the dependent variable in this case. So I'm going to go 3.5 times p equals 1 times t. Now I'm solving for p. P is my dependent variable, my y, and so I'm going to divide both sides by 3.5. Now we could have done this with x and y and then just change out our variables after. So I just decided to kind of skip that step. So I'm going to say the number of pages equals 1 over 3.5 times t. And I think if I go 1 divided by 3.5, yeah, it gets out to be a pretty non-terminating, non-repeating decimal. So I'm going to just leave it like this. So the number of pages equals 1 over 3.5 times t. So then I just type these numbers in and get out the number of pages. So in 0 minutes, he's going to type 0 pages. That's the proportional relationship right there, 0, 0. Now, if I had a scientific calculator here, I don't know if I can change mine into, I guess it isn't scientific. Here's how I do it. I put a parenthesis, 1 divided by 3.5, close parenthesis. You can see that right there. Then I go times, in this case, 5. I know some of you know how to, and I typed something. Oh, I put 35 again. Oh my goodness. I know some of you know how to put a fraction in there. I know you're going to approximate. I'm not overly concerned with any of that, but I'm going to go parenthesis 1 divided by 3.5, get it right that time, close parenthesis, times 5. And I'm going to try to type it correctly into my calculator. Times 5. And I'm looking, guys, it's going to give me not the right thing. Okay, I'm going to start over. Type this into your calculator, guys. It should work out to be approximately 1.4. Even though my calculator, nothing saved in memory. There we go. Try this again. Parenthesis, 1 divided by 3.5, close parenthesis, times 5. There we go. And you see it's about 1.4, 1.42. In your calculator, which is really nice, you have that saved in there so you can just keep changing it. I don't have that, so I might do one more here, and then I'll just go with the answers I've already come up with. 1 divided by 3.5 times, in this case, 10. And you're going to see that it's about 2.85, 2.9, maybe I'll say. So if I go 1 over 3.5, and I just want to, I'm waiting to approximate, so there's not as many or much of a rounding error. But all I'm doing is plugging the number of minutes in for t, and then I'm multiplying, typing into a calculator, multiplying, and hopefully I did this right earlier, and coming up with these approximations. Again, plugging these numbers in for t. Then I am just going to write these ordered pairs into this graph down here. So we have 0, 0, 5, 1.4, 10, 2.9. And these are going to be approximations. They have to be. Real life values don't work out so perfectly. So 0, 0, 5, 1.4. Here's 5, here's 1, 2, almost the halfway point, not quite. 10, 2.9, so that'll be just below the 3. And remember, I'm anticipating, since it's going through 0, 0, and it's a constant, it's proportional, it should be a straight line. 15, 4.3. And 20, right here in my picture, to 5.7. Okay, and again, we're going to see those are in a straight line. So we're just representing constant rates. We're writing equations so we can figure out, in this case, how many pages one can type in however many minutes. One more example. Emily paints at a constant rate. All right, constant rate. I know what I have to do. 32 square feet, 5 minutes. What area can she paint in T minutes? Well, I'm going to start here putting time on the bottom. 32 square feet in 5 minutes. Now, again, you can do this with X and Y. But if I look at my table here, my Y is going to be the A, the area, and X is going to be T, the time. I'm just changing those variables. I'm going to always solve for my Y here, in this case A. Then I've just taken out a shortcut. You can do X and Y, okay? You really can. So I have 5 times A equals 32 times T. Again, this is a linear equation, 2 variables. Don't just tell me what 32 or 5 is. That's not the answer. I need an equation. Solving for my dependent variable, my Y, in this case A, I'm going to go 32 divided by 5 and get 6.4. 6.4 isn't my answer. A equals 6.4 times T is my answer. So that's a linear equation in 2 variables. And now, just like we've been doing, type numbers into a calculator, find out the information, and graph it. So if I go 6.4 times 0, I get 0. If I go 6.4 times 1, they gave us our time here in minutes. It stays the same, 6.4. 6.4 times 2 is 12.8. 6.4 times 3, again, I'm just taking my T and plugging it in here. 6.4 times these things, 19.2. And finally, 6.4 times 4, and that's going to be 25.6. And guess what? We're going to plot it again. So I'm going to plot 0, 0, proportional. And again, I'm anticipating this is going to be a straight line because it's a proportional relationship. 1, 6.4. Ooh, notice our scale here is by 2s. So that's 7, so 6.4 will be somewhere in there. Make a big point so it looks right. 2 is 12.8. That's 13, so it's going to be close to that. 3, 19.2. And 4, 25.6. Now these points should look like they're in a straight line, which they for the most part do. A little human error in there. Okay, guys, one more thing. How many square feet can she paint in 2.5 minutes? We have our equation. Y equals 6.4 times T. It's not Y though, it's A. How much area? Well, this is minutes. T, and I'm just going to write 2.5 as 2.5. So we get to plug that in right here. And I'm going to go 6.4 times 2.5 is 16. So she can paint 16 square feet in 2.5 minutes. Now let's look at our graph here. 2.5 would be right here. If I did my line, 2.5, notice it is right here at 16. If I look here, halfway between 2 and 3, 12.5, 19.2, 16 would fall in there. So we can see all 3 of the different ways we can use, this is the most exact, to find out information from our variable using our constant rate, from our equation using our constant rate.